Z. This is our X. And this is rotation about Y. Okay. So I'm going to sketch this out. Okay. And this is supposed to be a hidden detail. Okay. Okay, now let me draw it as a hidden detail. Okay. And this is our element H. Okay. And then over here we have our neutral axis. Okay. And then we have a force. This is our 5 times 10 to the power 3 Newton. And we have I could not remember now, 12 times 10 to the power 3 Newton. Okay. So the only force we have to consider is this. Okay. So we are aware that there's a Vz already, right? Due to the 5 times, but the 5 times 10 to the power 3 Newton is going to induce a rotation about the neutral axis. Okay, so if I'm going to draw the deformation, okay, so we are going to have this rotate this way, right? And this is due to the 5 times 10 to the power 3 Newton. And the neutral axis did not change position at all. So when that's the case, it's going to be a torque. So therefore, torque in the y direction will be equal to 5 times 10 to the power 3, and then the distance, the radius is 0.15, right? Because this is still the radius. So this will be equal to 5 power 3. That's by 0.15 is 750. Okay. Okay. And then it's going to rotate in a anti-clockwise direction. Okay, so because the rotation, so it's going to rotate in an anti-clockwise direction. Okay, so we're going to take stock on the formula. Let's look at the formula. What is the formula that? What are the formula that we're going to use? So for normal stresses, we're going to use, we're going to have stress in Y is equal to Py over A, right? Plus by mx over Ixx multiplied by Z plus by mz over Izz multiplied by x. And then for the shearing stress, okay, so for the shearing stress, okay, the shear, well, so the shear, there are two components. Okay, so it's going to be T torque in the y direction multiplied by C, which is the radius, over J, right? And then plus by Bx over IZZ QZ over T plus by VZ over IXX QX over T. Okay. So what we can see, we know that MX over IX is multiplied by Z. Okay, so we know that this is equal to 0. So the next one is our shearing force. We only have Vx. We don't have we only have Vz. We don't have Vx, so we know that this is equal to 0. Okay. So now we can start determining our normal stresses acting on element H first. Okay. So let me paste this diagram. Okay. And then let me get the formula across. Okay, so the first thing we have to calculate is our area, which is pi r squared. And we know that radius is 30 millimeters. Okay, so 30 power minus 3 squared times by, so it's equal to 2.827. Okay, and then the second moment of area. Okay, so we know this is a shaft. IXX will be equal to IZZ. And then if we look at our formula sheet, okay, so this formula sheet will be provided. It's a quarter pi R4, okay, for a circle. So a quarter pi R4. So a quarter multiplied by pi, radius is 0.03 power 4. So 0.03 power 4 divided by shift pi divided by 4 is equal to 636.173. Meter 4. Okay. So from here we can calculate our stress in the y direction already. Okay. So our Py, if we go back, our Py is going to induce a compressive or Fy. Okay. So let me change to Fy. So this is equal to minus 12 times 10 to the power 3 divided by 2.827. Okay, and then we are going to look at MZ. Okay, so MZ, moment about Z is going to induce a compressive, a negative also. So minus MZ. So our MZ value, moment about Z is 1800. Multiplied by the radius, divide by 636.173 times 10 to the power minus 9. Okay, so this will be equal to 12 power 3 divided by 2.82. Okay, 12 power 3 divided by 2.827 power minus 3 minus by 1800 times 0.03 divided by 66.173 power minus 9 is equal to minus 89.128 or 127. times 10 to the power 6 Pascal. Okay. The next thing that we're going to do, we are going to look at shearing stress. Due to our VZ. Okay. So now if we draw, right? So if this is our shaft, okay. So I'm going to look at the plan view. So this is our Z, X, and this is our rotation Y. Okay. Ah, this is a shaft. Come on, EG. Right. So our Vy is acting in this direction. Okay. Right. So over here, if we're going to sketch how the shear flow will move, okay, the shear flow is going to move in this direction. Okay, I'm going to sketch the shear flow. Okay, so at the edges, it will be curved like this. But more important is I want you to look at the direction of this arrow over here. Okay, why I'm focusing over there? Because at this point, this is your element H. Okay, so the formula that we're going to use in terms of shear. So we are looking at shear. The area will intersect the z-axis, the y-axis, and is moving in the z direction. Okay, so this is equal to Vy over, sorry, Vz. Come on, Eugene. All right, so this is equal to Vz over Ixx Qx divided by T. Okay, so we know that, what do we know? We know that Vz is equal to, we calculated Vz is equal, I can't remember now, oops. Vz 5 times 10 to the power 3. We know that Ixx is equal to 636.173. We know that our thickness is equal to twice the radius. Okay, and it will be equal to 0.06 meter. And then we have to find our Qx. Okay, so to find our Qx is equal to A, right, Z bar. Okay, so the area that we have to consider is half the area. Okay, so half the area So this is the half the area that we have to consider. Okay, so half the area is equal to half pi r squared, right? And the z bar, right? We have to find where the z bar is. So if you go to look at this formula, right? The z bar is 4r 3 pi over 3 pi. Okay. So over here you will have 4r divided by divide by 3 pi. Right. So you can cancel here, you don't need the pi. So this will be equal to 0.03 power of 3 times 4 divided by 2 divided by 3 is equal to 18. Wait, half pi r squared 4 half I get it. Hold on, there's something wrong with me. Half 4r 3 pi. So the qx is equal to, wait, I get 18 times 10 to the power minus 6 meter cube. Okay, so from here we can find our yz. So this will be equal to 5 times 10 to the power 3 multiplied by qz divided by ixx and then the thickness is equal to 0.03. Okay, so 5 power 3 times of 18 power minus 6 divided by 636.173 power minus 9 divided by 0.03 is equal to 4. Okay, so the thickness is 0.06. I do apologize. Okay, because that is the diameter. So divided by 2, so it's 2.358 times 10 to the power 6 Pascal. Okay, I'm gonna stop here now, and I will see you guys next week. Okay, I will post homework today. Okay, for you all to practice.